Have you ever wondered what happens when two galaxies collide? Today we dive into the cosmic dance of galaxy collisions, a spectacle that unfolds over millions to billions of years and shapes the very fabric of the cosmos. First, let's establish the basics. A galaxy is a colossal system of stars, gas, and dark matter, held together by gravity. When two of these massive entities come within each other's gravitational pull, a dynamic interaction takes place. The nature of this interaction can vary. It might be a direct collision, a grazing encounter, or an extended gravitational tug-of-war. The outcome of these interactions is largely determined by the conditions at the onset of their approach. As galaxies draw closer, gravitational forces induce tidal effects. These forces stretch and distort the structures of the galaxies involved, often triggering intense bursts of star formation. In some scenarios, galaxies directly collide or merge, passing through each other to form a single, larger galaxy. Despite the enormous number of stars in each galaxy, the vast distances between individual stars mean that actual collisions between them are incredibly rare. The energy of a galaxy collision can compress interstellar gas, sparking increased star formation. Gas clouds collapse under the energy, giving birth to new stars in a brilliant cosmic spectacle. Sometimes a larger galaxy may cannibalize a smaller one, absorbing its stars and gas. This galactic cannibalism contributes to the growth of massive galaxies and the formation of structures like elliptical galaxies. At the heart of most galaxies, there lies a supermassive black hole. During a collision, these black holes can interact, eventually merging into a larger black hole and sending out ripples of gravitational waves in the process. These collisions can also transform the shape of galaxies. Spirals might morph into ellipticals, and the merger of multiple systems could result in irregular galaxies. To understand these complex processes, astrophysicists turn to computer simulations. These models help decipher the physics of galaxy collisions, while observations from telescopes like Hubble provide real-world data on these cosmic events. Galaxy collisions play a pivotal role in the cosmic evolution of structures in the universe, shaping the distribution and characteristics of galaxies over time. In conclusion, galaxy collisions are transformative events that display the power of gravitational forces on a cosmic scale. Through a combination of simulations and observational studies, we continue to unravel the intricacies of these collisions, deepening our understanding of the processes driving the evolution of galaxies in the cosmos.